This is one of our Bridgeport milling machines. To turn the machine on and off, we're going to use the switches right here. We have forward if you're running the machine in high range. We have reverse if you're running the machine in low range. And we have the stop button that simply stops the machine when you're done running it. Our Bridgeport milling machine has a brake on it. I tell everyone it's a good habit to get into. If you're running the machine, when you stop it, the first thing you should do is hit the brake. It stops the tool instantly, making it that much safer to work around. So let's go ahead and turn the machine on. We're going to run it in forward because we're in high range. The tool is spinning nice and fast. If we go ahead and hit the stop button, I've hit the button, that tool is still spinning, finally stopped. It takes that long or longer for the tool to stop. That's why it's a good idea for us to hit the brake. The brake on the machine is located right here, and you can swing out towards you or push it back. If you pull it off the machine, it does not do anything. It has to swing one of these two ways. So let's go ahead and turn the machine on, try to use it. Turn the machine on and forward. Again, we've done our machining operation. We hit the stop button. We hit the brake, stops the tool instantly. Again, it's that much safer to work around. If you're going to be reaching near that tool, it needs to be stopped. You might as well go ahead and hit the brake. If we're going to adjust the speed on the Bridgeport milling machine, the machine has to be running. Then we're going to use this knob right here. And we're also going to look at the indicator in the front of our machine. If we're in high range, we're going to be looking at the rabbit scale. If we're in low range, we're going to be looking at the turtle scale. We are going to be in high range, looking at the rabbit scale, running the machine in forward. Let's go ahead and turn the machine on. We can see the tool spinning nice and slow. Now I can go ahead and adjust this handle right here. We can see our tools spinning much faster now, and we changed the number that was in that indicator. Now we can go ahead and shut the machine off since we're done adjusting our speed. Making sure when we shut the machine off, we give the tool plenty of time to stop, or we use the brake before we reach anywhere near that tool. When we come into the machine shop, before we begin machining, we have to check the machine to see if it's in high or low range. If the machine is in high range, we're going to be running it in forward. If the machine's in low range, we're going to be running the machine in reverse. That also tells us what speed we're looking at. Forward for rabbit scale, reverse for turtle scale. So when we look at the machine, we're going to look at this lever right here. It is towards us. Right above it, it says it's in high range right now. High range is for softer materials and smaller tools. If we want to be cutting harder materials like steel, or we have larger tools, we will probably want to be in low range. To put it in low range, we're going to push this lever in towards the machine, swing it down around back. It locked in another D10, now it is in low range. Now we're going to be looking at the turtle scale, going nice and slow, and running the machine in reverse. Let's go ahead and turn this on. That tool is spinning nice and slow. Perfect for hard materials. So we're going to go ahead and shut it off and hit our brake to instantly stop that tool. So if we're done running the machine in low range, and we want to put it back in high range, we're going to use this same lever. We're going to press this in towards the machine. It's going to swing down around front. This lever is not yet engaged. What you have to do is grab this tool, not the sharp tool, right above it, the holder. Spin this by hand. That lever popped right into place. You want to make sure, you have to make sure that tool pops into place. If not, the gears in the head are not yet meshed together yet. That tool will grind. The gears in the head will grind. As soon as you turn the machine on, we'll hear it across the entire shop. We'll know exactly what happened. So make sure, if you go to put this into high range, you just give that tool a little spin, it should pop into place, you'll be good to go. Now we can look at the rabbit scale again, and we can run the machine in forward again, nice and fast. And then shut it off, always hit the brake, stop that tool instantly, making it that much safer. The quill of our machine is located right here. This makes the tool move up and down. We use this all the time. If I'm drilling a hole, I'm going to be moving this tool up and down, pecking the drill into the part. If I have an end mill, the tool that's in there right now, if we're going to be doing some milling, I want to set the height of this quill, and then I want to use my lock right here on the front. Just snugging this down, now my quill, the height of my tool is locked in place and can't move. That's very important. If you are milling something and you forget to lock the quill in place, it's not locked, it's up, and you start milling, with just a small amount of pressure, that tool starts moving when we don't want it to. That can be very dangerous if you're milling something and the height of the tool bit is changing when we don't want it to. So make sure if you're going to mill, you lock this quill down in place. Just snugging it up is fine. If we don't like the location of this quill handle, we can snug the quill up in place. Then we can pull out the quill handle. We notice this handle is moving around, yet our tool is staying in the same spot. It's not locked in that same detent. Whenever we let this handle go, it will click in towards the machine, locking in a new detent, and then you can use the handle from there. A good reason to do this, if your hand is down here nice and close to this tool, and there's chips spinning around, you could cut your hand. You might want to move this handle up here out of the way. Also, when you're milling and you're drilling stuff, it's a lot easier if you're up here pulling down. If you find your hand down here trying to push down and around back, it's very uncomfortable. But depending on what you're doing is where you're going to want to locate this quill handle, whatever's comfortable for you and safe. As we're using our quill handle, we notice our tool is moving up and down. There's a block right here moving up and down as well. That block is part of our scale and stop system. If we look on the side, there's a scale that's right next to that block. We can move this block down and we look at the bottom of this block, see where it's lined up with that scale. If we come down and we are roughly right at 1 inch and we have just touched our part right there, we can move that tool down an additional 1 inch on our scale. That's a nice quick way to measure something. It's not the most accurate way, but it is nice and quick. For things that don't matter, like depth of holes, I use that feature all the time. When we're working with our quill, we also have our stop. Our stop is located right down here. We can fine adjust this by threading it, by turning this, and it's going to thread up this threaded shaft it's sitting on. Or there's a button right here on the front of that. We can push that to the side so we can get a couple fingers around it and pinch this and slide it to where we want. If I slide the top of this block right to that 2 inch mark, when my machine comes down, my tool's coming down, this block is coming down, it's going to hit that stop. That's as far as that tool can go. I can't go any further. That's a nice way to stop the tool. If we want to make 100 holes all the same depth, that's a great way to do it. I use that feature all the time. You have to remember when you're done using that feature, if you want to continue using the Bridgeport milling machine, you don't forget this stop is stopping our tool from coming down any further for different operations in the future. We can just put that down out of the way. Now our tool can go down a lot further. We won't have to worry about that stop being in the way. This is the vise on the Bridgeport milling machine. This is how we hold 99% of our work. Nice and simple. Open it up or close it up. If we're going to hold a part in that vise, we're going to place our part in that vise, nice and flat down on the bottom, making sure it's clean and there's no chips or debris underneath our part influencing how it's sitting. And then we're going to tighten this handle and make sure 2 hands nice and snug. If we take this tool or we take this part and put it in this vise and we just put it in there, it's being held right now, but I only tightened it with 1 finger. That is not tight enough. If I grab this tool or this part, I can just bend this. It's not tight. When I go to machining, that part will move. You will damage something. You could possibly get hurt. So when I'm putting it in there, again, 2 hands, nice and tight. If we're working on a Bridgeport and we're going to machine our part, we put our part down in this vise and the top of that part just disappeared. We can't see it anymore. It's not tall enough to start working on. We're going to have to use a set of parallels to raise our part up to a height where we can actually machine it. This is a pair of parallels right here. The top and bottom surfaces of these parallels are even. They're exactly the same. They're a matching pair. We want to make sure they're nice and clean. Put them in our nice and clean vise, one on the back, one on the front. Now when we put our part in there and rest it on top of those parallels, it is sitting parallel to the vise still. That's where we're going to tighten it. Nice and snug, 2 hands, nice and tight. Now we can machine the top of that part because it's protruding from the top of the vise. If our parallels are too wide and we want to try to drill these holes down through our part, we can hit the parallels. So we always need to watch where that tool needs to go. If the tool is going to hit something, we're going to have to get different parallels, change our setup, move our part to a different location, making sure nothing that we don't want to hit gets hit. This machine is a 3-axis milling machine. We have X, Y, and Z. X-axis is our longest axis right here. It goes left to right. There's a handle on either end, whatever you prefer, whatever's more comfortable for you, depending on what operation you're doing, what handles you're trying to hold, whatever's more convenient. Y-axis is right here in the front. Y goes in and out. Z-axis is right down here. You have to put this handle on, make sure the teeth are engaged, and then it very slowly goes up or down. When you're done using Z-axis, you can simply slide this handle off, put it on backwards, and it tucks underneath the machine, making it a little safer. You won't walk into it or hit it. Nobody will accidentally bump it on you either. It's nice and convenient. Every axis has a lock on it. We talked about our quill lock up here that we use very often. Our X locks, there's 2 of them on this machine. Some machines just have one. One's right here, one's underneath the vise here. If we snug those up, X-axis is now locked. It's tight, you can't move it. It's either going to be locked solid, you cannot move it, or it's going to be very hard to move. In either case, check these locks, making sure they're down, swinging free. Now our X-axis can move freely again. Our Y-lock is hidden underneath the left of the table under here. Our Z-lock is right underneath the Z handle, kind of hidden away. If you come up to a machine and it moves very hard or does not want to move, don't try to force the handles. Make sure you check all of the locks, make sure they're unlocked, then the machine should move fine. This is our readout on our Bridgeport milling machine. It keeps track of our X, Y, and Z based off the origin set by the user. If we want to zero one of our readings, we have X right here, Y, and we have Z. So if we go to zero one of those, we simply hit clear. All of these numbers are going to begin to flash. Then we want to select the axis that we're working with. Let's clear X. So I just hit X. X is now reading 0. Our readout is reading in inches and 3 place decimals, 0.001 resolution. 1/1000th of an inch. A human hair is roughly 5/1000th of an inch. So we're reading to a 1/5 of a human hair. It's very accurate. So depending on what you're making is how critical you need to pay attention to these numbers. We don't want to be off a decimal place. We don't want to have an extra 0 or a missing 0 in a certain location that will certainly matter. But if you are off 0.001, that's not usually too big of a deal depending on what you're making. Most of the time, prototype, quick designs, the projects in the innovation machine shop, if you're off 1/1000th of an inch, that shouldn't matter too much. So don't stress over getting that last decimal place perfect. To change tools on our Bridgeport milling machine, we want to make sure our quill is unlocked, and then our quill can move around on us. We're going to raise that tool all the way to the top, and I'm going to hold onto the tool, not the sharp part, but this black ring right above it, and we're going to push back on this handle. So I'm holding that tool, and I push back on this handle. That tool is simply going to fall out of there. You don't have to pull it out. It's going to just fall out. You just have to hold it to make sure this sharp tool doesn't hit the table or anything underneath it. There's a keyway on the side of this tool that's being used. So when I go to put that tool back up in, it hits. The keyway is not yet lined up. We have to rotate this tool around till we find that keyway. And then that tool is going to go up inside. If we let go, it's just going to fall out of there. So we have to hold a little upward pressure on that tool. Then we're going to push back on this quill handle again. The tool is going to recess up into the machine. And then we can let the quill handle back down. That tool is now being held again. Some of the different tool holders we have for this machine. This is one of our collet holders. It just holds end mills. We want to make sure if we're using a drill, we use a different type of holder. This collet holder with the black ring on it is just for end mills. There's multiple different ones up here. This holder right here is the exact same kind as this one. There's just no black ring set up on there. So if we find an end mill, let's say we just found this end mill right here. We have to measure the shank, the smooth part down here that we're holding. And then we have to make sure we find a collet holder with the same size hole in it that exactly matches that shank diameter. Then we can, if there's no black ring on this holder, get a black ring that's not in use. They unthread. This part goes on the bottom. It just drops right on. And then this threads on top. Now we can use this holder with the new tool that we have. The other main type of holder we have is our drill chuck. Just the same thing as in a cordless drill. This will be up in the machine. To tighten this tool, or to loosen this tool, we spin the bottom part. We see those 3 teeth coming out, clamping on our drill, or loosening it, letting our drill come out. You have to make sure when you put a drill in here, we're being held on all 3 jaws inside of that drill chuck. We don't want to be on too crooked, the tool will be wobbling around. It's not very safe. If we need to go ahead and change a tool that's in our collet or endo holder, we're going to need to grab that tool, our hammer, and our piece of PVC pipe. On this side of the table, there's a small block we can put our tool holder into. We need to spin it until the keyway lines up. That tool will drop down into place. Now it can't rotate while we're trying to loosen that tool. We need to use our spanner wrench that should be located on the machine to loosen this top black ring. We're going to put this pin in one of these holes and we're going to loosen up this top ring. Once this top ring is loose, we're only going to loosen it half a turn. This tool is still tight. We cannot grab this tool and try to pull this out. That tool is very sharp, we could get cut. We need to take our piece of PVC pipe, put it over that tool, take our hammer and give that a good hit. If the tool does not come loose like that, we need to do it again with a better hit. That tool is now loose. It fell down into that holder. Now we can carefully remove that nice sharp tool from the holder. Then we could, if we want, change tools and put the new one in. When we put the new tool in, if we drop it in, it's just going to fall right to the bottom of that holder. That's not where we want it. We're holding up on these sharp flutes that we're trying to cut with. We also don't want to hold just the end of it here. It's not rigid enough. We want to hold somewhere around here. So we need to hold that tool the height we want and then snug this black ring in place. After that's snugged in place, we can use our spanner wrench to go ahead and fully tighten that, nice and snug. As soon as you're done changing a tool in this holder, we have a nice sharp tool sticking up in the air. We want to go ahead and put this in the machine if we're ready to machine with it, or in the tool holder if we're not yet ready to use it. We do not want to see a tool left in this holder. It is very sharp, sticking right up in the air. It's very easy to reach past this tool and get cut. So as soon as you are done changing this tool, put it in a safe location. We're going to put this back in our tool holder, as well as putting our piece of PVC pipe and our hammer back as well. Now our tool is changed. We're ready to use it later on. Perfect. When we want to edge find using our Bridgeport milling machine, we have to use our edge finder. The edge finder is loaded into the adjustable drill chuck. Our machine is going to be in high range. We're going to be running the machine with the forward button, and our speed is going to be about 1500 RPM. Our goal is to find where the back edge of this part is and set that edge to 0. So I'm going to go ahead and use our quill to lower the tool so the bottom of the tool is just below the top of the part, and I'm going to snug the quill up so the height can't change while I'm trying to use it. I'm going to now turn the machine on in forward, and then we're going to go towards our part, trying to touch that part. I'm going to turn the machine on and forward. The edge finder is the only tool you can touch while it's running, and you can just bump the edge of this, the bottom of this, with your fingernail, and it starts to wobble around. It makes it a little bit easier to see when you're touching your part. I'm going to now use the Y-axis to move towards my part. I'm slowly moving towards that part. As I get close, I have to go really slow to make sure I'm going slow enough so I can see when that tool kicks off to the side. It's almost concentric right now, getting nice and smooth, and I keep going very slowly, and that tool kicks off to one side and just sits there. Right when that happens, stop. Don't touch anything. You then need to go to your readout on your machine. We're working with Y-axis. We need to hit clear and then Y. So Y is now set to 0. Now we need to go back to our tool, our edge finder, and back up and touch again, very, very slowly, touching that tool off of our part. And again, as soon as that kicks off, we stop. We don't do anything. Our readout should read 0, the same number we just set. If it does not read 0, you are going too fast. You need to start over and do it all over again, completely from the start. Now we can shut the machine off, and I'll hit the brake to stop it. Right now, what we have done is just set the diameter of this tool to this back surface. We want to get on the center of that tool. So we need to unlock our quill, raise our tool up above that part, and move our Y-axis, the radius of this small diameter. That diameter is 0.2. So our radius is going to be 0.1. So I'm going to be moving towards my part, 0.1. It's kind of hard to see. Moving 0.1. So my readout is now adjusted 0.1 towards my part. If I look from the side, I am right on the center of that tool. So I have moved 0.1 towards my part, or on top of my part. Now I need to clear the readout again. So I just reset Y to 0 again, while my tool is right on that back edge. So now that back edge is set to 0. If we want to do the same thing to the X-axis, it's the same exact process. We're just going to be working from down on the end of our part. I'll move my tool down towards the end of the part. I'm going to turn the machine on in forward within a high range, about 1500 RPM. I'm going to lower that tool down, and then I'm going to go into the side of that part very, very slowly until it kicks off. And it just kicked off right there. And I'm going to clear my X-axis this time. Clear X, perfect. Again, you always want to recheck. Nice and slowly going towards that part. And it kicked off right there. My readout is off 0.001. That is fine. That's close enough for what we're doing right now. If it was off more than 0.001, I would do it again. So again, now we can shut the machine off. We can hit our brake. We can raise the quill so we're up above our part. Now we are going to move towards the part. We can be able to see a little easier over here. We can move towards the part, 0.1. So now we're on the center of that part. My readout reads X, 0.1. We're going to clear that readout again. Now my X-axis is set right on that left side to 0. X and Y is now set. If I move my readout, I'm moving my machine around. So X is 0 and Y is 0. And we look at where our part is. X right on that corner. We'll come over to Y right on that corner. It looks good. If you get done edge finding X and Y, put your machine on 0, 0. Look at your part, see where it is, see where the edge finder looks like it is. If you get done and your part looks like that, it's not on the center of that tool, or it looks like that, it's further off, you need to restart and do it again. You either forgot to offset the edge finder, your 0.1, your radius of the tool, or you went the wrong direction. Either case, it's going to mess up your part. You're going to be off. You need to start over and make sure it's good. So quick double check when you're done makes it really easy to make sure it's correct.